So there were a few different ways that you could draw the warm-up. Remember, each of these rays is starting at A. A is the endpoint, and it goes through those other points. So here's ray with endpoint A. It goes through B and C and D and E. Those are all separate points on this ray. Otherwise, if all of these rays meet at endpoint A, here's one that goes through point D, B, E, and C. So either way would work here. Today we're looking at angles. An angle is formed by two rays that share a common endpoint, provided that the two rays are non-collinear. That means they cannot be on the same line. The common endpoint is called the vertex of the angle. And the two rays are the sides of the angle, as seen below here. So the vertex is just a point. Here the side is ray BA. Here this side is ray BC. So you can name the angle in the figure above, angle ABC, or we could say angle CBA, or we could use the angle symbol. So here's our angle symbol, angle ABC or angle CBA. Notice that the vertex must be in the middle. So our vertex was B. It's always in the middle of these angles. The first and last letters each name a point on a different ray. Since there are no other angles with vertex B, we could just also call this angle B. So we want to name all the angles in this drawing. Here's one angle. We could say angle UTV, or since there's no other angles that share this vertex, we could just say angle T. Here in green, we could say angle UVT. Remember, the vertex is in the middle. Or since there's no other angles that share vertex V, we can just say angle V. Here, oops, that was a V. Here in blue, we have angle VUT, or you could have said angle TUV, but we cannot just call this angle U because angle 1 also has its vertex at angle U. And we could call that last angle angle RUV, or if you want to call it angle VUR, that's fine. But again, you can't call it angle U because there's two angles with vertex U. The measure of an angle is the smallest amount of rotation about the vertex from one ray to the other. It's measured in degrees. The measure of an angle can be between 0 degrees and 180 degrees. And we use what's called a protractor to measure those angles. So we have some steps for using a protractor. We're going to place the middle of the protractor on the vertex of the angle. So it's kind of hard to see, but here's our angle, here's the vertex. This middle of the protractor is right on the vertex. We want to move the protractor so one of the rays is pointing towards 0. Well, here's a ray, oops. Here's a ray, here was 0, it's pointing directly towards 0. We want to follow the numbers until you get to the other ray. So see how there's two sets of numbers? This one starts at 0, this one starts at 180. Since we wanted this ray to be pointing to 0, we're going to follow this inside track of numbers all the way up until we get to 50 degrees. So that symbol is the same as if you said degrees Fahrenheit, degrees Celsius. Example 3 we're actually going to get to on tomorrow's starter. Get you trying to use the protractor on your own. So you can skip that section. Two angles are congruent if and only if they have the same measure. Use identical markings to show that two angles in a figure are congruent. So just like before, when we had congruent segments and we use those tick marks to show they were congruent, we do the same thing with angles. So here, these two angles have an arc with just one tick mark. That means angle DOG is congruent to angle CAT. If we took the protractor and measured them, they'd have the same measurement. Instead of using tick marks, sometimes they use the same number of arcs. So here we could say angle S with one arc is congruent to angle B. Angle R has two arcs, so does angle A. Those two angles are congruent. Angle T has three arcs, so does angle C. A ray is the angle bisector if it contains the vertex and divides the angle into two congruent angles. So we talked about the midpoint being a bisector before, cutting it into two congruent parts. Same with an angle bisector. So in this figure, here's ray CD. It bisects angle ACB since these two angles are congruent. So we want to use the figures at the right, name each angle bisector and the angle it bisects. So here, 44 degrees and 44 degrees, these angles are congruent. So that means, we'll call this figure 1. In figure 1, ray GE, endpoint at G went through point E, bisects angle HGF. Again, we have to use three letters here since there are more than one angle that share the vertex G. Could have called this angle FGH if you wanted. And in figure 2, even though we have two congruent angles, there's still this angle in the middle. So the ray doesn't divide it into two angles. Here we have kind of three sections. So there really is no angle bisector. Then we want to name all the congruent angles in the picture. So if we're talking about figure 1, we could say angle HGE, remember vertex in the middle, is congruent to angle FGE. We have to use three letters to name those angles. And even though 2 didn't have an angle bisector, we can still tell by the markings that there's congruent angles. Angle YMN is congruent to angle EMO.